Okay, now what we want to talk about is direct and indirect variation today. So basically direct variation, we talked about it in the notes, was that it's a constant slope and it always goes through 0, 0, where inverse variation doesn't necessarily have that. So the constant of the variation, k, okay, that's our constant with a k, okay, is also known as the slope of the function. And there's two types of variation, and of course we just talked about it. It's direct and inverse variation. Okay, these are the two ones. So graphs of direct variation. Here we have two graphs showing a constant rate of change, basically, or a constant slope that's going through 0, 0. To find the constant variation and the slope of each direct variation. Basically, you're doing the exact same thing. The constant of the variation is our slope. So I'm going to say y2 minus y1 all over x, and I'm putting it in exponential form, which I should be doing as subform, y2 minus y1 all divided by x2 minus x sub 1. So I have a point here which is negative 1, 3, and of course I have 0, 0. So I can go ahead and say, okay, my y values, again, I like to underline my y values so I don't get messed up, or circle my y values so I don't get confused. So I'm going to say 3 minus 0 all over negative 1 minus 0. Basically, it's pretty simple, right? So I'm just saying 3 over negative 1, which is negative 3. That is my constant of the variation, also known as my slope. Okay? Here, I have 3, 1, and I have 0, 0. All right, so I could go ahead and say, use my slope formula and say y2 minus y1 over x2 minus x1, and I have my y values, and so 1 minus 0, 1, 3 minus 0, 3, and that's going to be my constant of the variation, 1/3. I really didn't have to subtract that. If you look back, I have this point 3, 1. Let's think about this. If you have a line that goes through 0, 0, all you have to do is put your y value over your x value. That's the only case that you can do that. If you have a y-intercept of anywhere else, up here or down here, it's not going to work. But so you can just go ahead and do that. Let's look at another point. I have negative 3, negative 1. Y over x, negative 1 over negative 3. Again, it becomes positive 1/3. So it would work. You might have to reduce it, but it would certainly work. Okay, so let's go ahead and look at some examples here of direct and inverse variation. Okay, when x is 2 and y is 4. Okay, find the equation that relates x and y in each case. For 3, it says when they vary directly. So for that, I'm going to say my constant equals y divided by x. Or I can go ahead and say 4 divided by 2, which is going to be 2. For 4, it says when they vary inversely. For inverse, what we want to do is we want to use the equation. And I'm sorry I didn't refer to this before up here at the top. Here's our equations when we're talking about direct, which we talked about last class. And here's our inverse variation. And so we have y equals k divided by x, or k equals xy. So I'm going to use that. I'm going to say k equals xy, and I'm going to go ahead and say 2 times 4, which is 8. Okay, so when x is 3 and y is 12. All right, find an equation that relates x and y in each case. When x and y vary directly, again, for number 5, I'm going to go ahead and say y divided by x, or k equals 12 divided by 3, which is 4. When they vary inversely, which is k equals xy, or I can go ahead and say k equals 3 times 12, which is 36. Okay, so we should start seeing the difference between direct variation and inverse variation based upon some of the formulas that we're using. So on the back here it says the variable xy vary directly when x is 3 and y is negative 30. Write an equation that relates x and y and find a value of y when x equals 8. Okay, so for this first one it says it varies directly. Okay, so what I'm going to say is k equals y divided by x, and so that's going to be negative 30 divided by negative 3, which gives us positive 10. And then we can go back, now that we found out what k is, we're saying k is 10, now we can find the value of y when x is 8. So now I'm going to go back and say y equals kx, and that's going to be 10 times 8. And so y, when x is 8, y is going to be 80. Okay, now we have them where x and y vary inversely. Okay, so that means we need to use our other formulas that we have at the top of our notes on the other side. So it says, write an equation that relates x and y. So my constant is going to be 4 times 20, which is 80. Now that I know that, I want to use y equals k divided by x. So I'm going to say, and it says x is 10, so it's going to be 80 divided by 10. So when x is 10, y is going to be 8. Now, the next table tells us to decide, based on this data, whether it shows direct or inverse variation. So what we need to do is we kind of need to go back and look at our equations for direct and inverse variation. Okay? So basically what this is saying, for direct variation, y divided by x, every y divided by x, we would have the exact same constant. For inverse variation, x times y would give us the exact same constant. Okay, so that's what we're looking for. So let me go ahead and test this one for direct variation. Direct variation, I'm just going to say direct variation, okay? The formula we're going to use is constant equals y divided by x. And if we look at it, every y we divide by x, we should end up with the exact same k. So 2 divided by 1, that equals 2, okay? Y divided by x equals 2. 4 divided by 2, that equals 2. 6 divided by 3, that equals 2. 8 divided by 4, that equals 2. So this is direct variation. Okay, this is showing me direct variation right here, because every time I divided my y value by my x value, I got the exact same constant. Okay, so let's go ahead and test this for this one. Let's see, we want to start off with direct variation. We'll say y divided by x. 8 divided by 1, that equals 8. 4 divided by 2, that equals 2. 8/3 divided by 3, that's going to be 8. And 2 divided by 4, that's 1/2. And I might have messed up on that math there. Well, we can already see that we're not ending up with the exact same constant. Okay, have you noticed as I divide y by x, I'm not getting the same constant. So let's try inverse variation. All right, inverse variation says that the constant equals x times y. So anytime you multiply your x and y values together, you're going to get the exact same constant. So let's see, 8 times 1, now I'm multiplying, I'm not dividing like I did up above. 8 times 1 equals 8. 4 times 2 equals 8. 8/3 times 3, that equals 8. 2 times 4, that equals 8. So that's showing us that this is inverse variation. Okay, thank you.